Good day, everyone. Welcome to NLC Laser. Today we are servicing a Deka 30-watt medical laser tube. It has been sent back to us for a regassing because the gases are starting to fail inside the laser tube, and we need to evacuate those gases and put in some fresh gas. And this is indicated by low power levels, which you saw at the beginning of the video. We are running at approximately 25 milliamps of tube current, which is indicated on this current meter. And we're getting out a little bit over 10 watts, maybe 12, 13 watts. This is less than half of what it should be for this current. When we're done processing this laser tube, we will get anywhere from 39 to 42, 44, 45 watts out of this tube with new gases. When the laser tubes are shipped in to us, the first thing we do is we bench test them as they came in, so we've got a baseline and we can look at what the beam quality looks like. We can look at the catalyst that's on the inside of the bore looks like. We can look at the quality of the optics. Are they dirty? Are they clean? Are they heating up? Just to do a kind of an overall baseline evaluation of the laser tubes. And then once we're done with that, what we do is we actually open up the laser tube. There's a little glass nipple here. We open that up and attach a fresh nipple, attach that to our vacuum system, evacuate the gases, and it has to reach a certain vacuum level before we'll go forward, at which time we will backfill it with a proprietary mix that we have created over the years, and then we'll test it. And depending on the results that we get, we will either tweak things or we will seal the laser tube and repackage it, and it's ready to go. So like I said, we are experiencing very low power out of this laser tube at maximum current, and we will come back and show you what this looks like after we're done regassing it. So one of the other things that we do once the tube is finished being regassed and sealed off is we document the mode quality. And what you're looking at in the viewfinder is the front face of a power meter, and we have we call it mode paper, but it's simply heat sensitive thermal paper. We put it in front of the beam and we do a fire. This is at 15 watts, and it gives us a visual indication of what the beam looks like. Is the beam nice and round? Is the power density uniform across the entire width of the beam, and so on. This looks great. This is exactly what you're looking for in a tube that's performing properly. We have put a tip off on the laser tube. We've opened it up. We've evacuated all the old gases out of it. We've attached a new glass tip off, which allows us to connect up to our pumping station, and we have pumped it down. We normally pump down overnight, and this morning we were at the vacuum that we wanted, so what we did then is we backfilled the laser tube with our proprietary mixture of gases. We tested it, everything looked fine. We then pinched off the glass tip-off port, so now we have a full functioning tube just like it was brand new out of the factory, getting great power results. It's stable from less than 2 watts all the way up to we're getting 42 watts out of this particular tube. I'm going to zoom in on that in a second so you can see what kind of powers we're getting. Just great performance out of this tube. And this is very typical of the Deka tubes, or LN tubes. They go in not only the Deka systems, but they're also used in the Cynosure laser systems as well. Both lasers are manufactured by the LN group in Italy. If you're in the United States, Canada, or Mexico, it's much cheaper to come through us and to get your tube refilled through us and through one of our local service engineers that can install it and calibrate the system for you, and then to ship it back overseas to China. So anyway, I'd like to thank you for watching our video, and now I'm going to zoom in and do show you how the power levels look at different currents. And then we'll call it a day. So thank you. So here you can see we're looking at the power meter, laser power meter on the right, and the current meter on the left. You can see this tube is happily producing 42 watts at approximately 30 milliamps of current. Nice and stable. Then if we start backing down the current here, obviously the power will come down. So let's go down to 30 watts and just verification that the laser is operating in a nice stable format with no major power fluctuations. So there we're nice and stable at 30. Nice and stable at 10. And then we'll go down to about 1 milliamp of current, which will put us right in about the 2 watt range. And you can see even at the low end we have nice stable performance. Laser's operating just like new. We also have the ability, should the opportunity occur that you need optics replacement, we do that. We carry in inventory optics for the Deka Cynosure tubes as well as the Sharpland tubes. We also have specially designed shipping boxes for these units. And if necessary, we can also replace not only the catalyst that's on the inside of the bore, but we can also replace electrodes too if that's necessary. And if you run into a situation where somehow the tube has been broken, under many situations we have the capability to repair the glass and bring it back to normal operating performance as you see now. So anyway, thanks for visiting this YouTube presentation by NLC Laser, and we hope to talk to you soon.